Alright, hello everyone, it's March the 9th. Alright, let's do this. A bunch of easy problem to go through. That'll be good. JavaScript, no. Java. Alright, minimum common value. Two integer arrays sorted in undecreasing order. Return the minimum integer common to both array. If both array have at least one occurrence of that integer. So it's already sorted. So basically it's 2 pointers and we just go. Yeah, it's like merge sort but without actually the sorting part. Alright, let's do this. Wipe int I 0, int j 0, while I smaller than nums 1 dot length and j smaller than nums 2 dot length. Right, and then we say if nums 1 I is equal to nums 2 j. And then in this case, we are going to return nums 1i. Right. Else, if nums 1i larger than nums 2 j, in this case, then j plus plus. Right. Else I plus plus. And then if nothing, we'll return -1. I want to do some edge case. Okay, let's just run some edge case. So this is merge sort without a merge. Okay. I'm gonna put a time. Binary search. This is O. Okay. Max pair sum in an array, or given a zero indexed array, you have to find a maximum sum of a pair of numbers such that the maximum digit in both. What? Let me read again. Okay, we get nums. You have to find a maximum sum of a pair of numbers such that the maximum digit in both numbers are equal. That is so random. Alright, so we want to find, so given each number, I have some digit. Yeah, so you just record the digits, right? Yeah, we record the digits. Like contain digit 5, which numbers contain digit 5? Digit 1, which one contain digit 1? And Actually, no, we need a biggest digit, right? So for each number, we need to find its biggest digit. Okay, each number, we find its biggest digit, and once we find that, we put it in, let's say, an array, right? We put in an array. Okay, so now we have biggest digit, and then we have a bunch of arrays. And what we want to do now is want to find a maximum of a pair such that, so basically, for each digit, we have a list of numbers. We can sort it and choose the biggest two, add them. Okay, so we can do that. And then in Python, this will actually be not that bad to code up. Oh, I'm so tired. It's like a theme for every day. It's always like I'm so tired. Alright, so what we need the default dict. Default dict to digit digit num map. Default dict list. I have to say collections. Oops. Okay. Then we say digit this max str_n dot append n. Okay. And then rest equal to 0 for v in digit num dot values, right? And then if len v is large equal to 2, v dot sort, and then rest equal to maximum rest v minus 1 plus v minus 2 to rest at the end. Oh, that is what's asking for, right? Okay, so we should start with minus 1. Prepare, right? Prepare a list of numbers for each max digit, then return the max sum of the largest two numbers in each list. What's the we'll have the on, that's on plus values, and then we have the sort. I think probably overall is O and log n. That was a guess, but let's try this. Yeah. Oh my god. Are there any better solutions? max D. Ugh. How is log n a log m? I don't understand. Ah, I see. It's all right. These easy questions is okay. All right, maybe you have time for one more. Let's read it one more, see how tough it is. And then based on how tough it is, I'll decide to do it or not. Double a number represented as a linked list. Head of a non-empty linked list presented a non-negative integer without leading zeros. Return the head of linked list after doubling it. The number of nodes in each list is pretty big. And the input is generally such that the list represents a number that does not have leading zero except the zero itself. Okay. So we can reverse it, you know. We can reverse it, and then starting from this position, we can just add and then we reverse back, right? That's definitely one way. Or we can just get one, double it, create a new one, depending on what type of method you want to use. I mean, I think it'll be more interesting to I'm gonna just use the okay, how about we do both? Right? How about we do both? You happy? Right? We do both. Alright, I do both. Okay, so this is solution 1. Get the number, get the actual number. Oh, I cannot use it. Double it. And then create a new linked list from the double. Alright, so we can say original is 0 and node equal to head. Right. While node original equals original times 10 plus node of val, node equals node of next. Okay, and then double db shall equal to original times 2, right? And then we basically said new head. We can actually do it this way. Let's tr this thing, right? Now we say new head list node val equals to db int db 0. Okay, then we say node equals new head. So while for d in db. No. We can do this. Yeah. Node dot val shall equal to int d node dot next equals new, not new, we just go list node equal to node dot next. Okay, now you return new head. Alright, something like that. Okay. Why is that 0? Yeah, db is right, so the problem is with here. So we got a new head, which is fine. But d and db, so first one, this equal to this, so no, we have a next. The last one we have next. Ah, that was the problem. That was the problem. All right, so what we're gonna do is dummy, and then node shall equal to dummy. All right, so we shall do this first. Right, node on next equals to val equal to int d. Then we do this, node equal to node on next. That I think will be correct. Oh, we should say dummy on next. Okay, that should be right. Yeah, need to use the dummy. Dummy is a good thing. Oh! Wow, I thought we can get away with it. I thought we can get away with it. Holy crap. Oh. That's very interesting. I never had this before. Which is good. Okay. It's good. Very good. My. So, yeah, okay. So I cannot do that. Okay, this solution with error. What's the error? Exceeds the limit for integer string conversion. All right. Exceeds the limit, which is 4300 digits. Okay, so can you do it? I mean, the multiplication definitely works. It just cannot convert, right? I mean, I can go from back to forth, but I don't want to, right? If you want to do it, you might as well do the other way. I'm just trying to see if it's possible to, yeah, that you have to do like a log or something like that, or divided by the total number. Oh my goodness. Yeah, okay, this is exceeds the limit for integer string conversion, right? For integer string conversion. So the lazy method, right? Lazy method doesn't work. We will have to reverse. That's fine. I mean, we kind of already we're thinking about the reverse anyway, so it doesn't really discourage me at all. I was trying to try different things, but it's okay. All right, so this one is we reverse the linked list. Okay, so we can say def reverse self head. Ooh, hold a second. Will it be empty? No, it won't be empty. What do we return? We need to return the new head, so we return a new list node. Okay. All right. If I remember right, we're gonna have to have so we need a dummy, right? Yeah, we have a dummy. The first thing we do is this pointing back to the dummy. Move forward, and then this pointing back. And forward all the way to the end. We reverse it. Okay, so we probably need a dummy as well. List node. Next, shake the head. Okay. Then what? Then we have pre and current shall equal to dummy and head. So while current temp shall equal to current on next. Right, and current dot next, so point to pre. After we do that, then we say pre-current shall equal to current and temp. All right, all the way into the last one, pre-current, so current become none at the end. Yeah, so pre is the head, but we need to say head dot next shall equal to none, then we return pre. Okay, so that's reverse. So what we'll do is we'll call self reverse head. Alright, so we're gonna say tail is gonna be this, right? And then we are going to create a new stuff, right? New stuff. We can also do a dummy. Right, we can do a dummy and then point into the head. Right, and then after we do that, we will reverse it. Yeah, so we can say a dummy equal to list node. Okay. And then node equal to dummy. So we have a node. We also have the original node. Right, original node shall equal to tail. Because original node is equal to tail. Actually no. Maybe. Then we just say while original node, right? While original node. Then node dot next shall equal to list node. Oh, we need a carry as well. So carry is equal to c equal to 0. Right. So this will be this this node val shall equal to original node is times 2, right? Original node. Hold a second. Let's say value and a carry shall equal to div mod original node dot value times 2 plus c. So what's div mod? I forgot. No, we just need to go f. No, not f. Wait, what's the thing? Is show the control F? No. Shift K. Shift K. Okay, Shift K. We have Shift K and then Control K. Okay, Control K nothing. But Shift K. We can do Shift K. I have no idea what you return, man. I forgot. What do you return? Div mod. What does div mod return? Quotient. No, quotient and the remainder. Okay, quotient and the remainder. Yeah, so quotient is remaining, remainder is quotient, and the remainder carry is now remainder. So this is actually carry. This is gonna be v, right? Carry is carry, and v is v, and then we can do now value shall equal to v. Okay, and then node.next, and no equals node.next, right? No equals node.next, and original node equals original node.next, right? So the first one, we get this node.next equals this, and then move on, blah blah blah. Once we're done, okay, once we're done, we have to check if c is larger than 0, right? If c is larger than 0, then we need to put one more, right? So original node dot next shall equal to list node val equals c. Okay, that's fine. We don't have to point to the we should node equals node dot next. Okay, all right, once we're done, we're gonna call self dot reverse dummy dot next. All right, dummy dot next, then we reverse it, and then we return node. Oh, yes, sorry. Should be done. Do one more. Argument of type unknown cannot be assigned to parameter head of type list node. That's okay. I'm not gonna worry about that. All I want to worry about is submit this and call it a day. All right. Base case, is that correct? It is correct. And I'm gonna throw this giant case. Is that correct? And that is correct. Yeah. Should have tried it beforehand. I mean, it doesn't matter. Even if you tried it beforehand, you probably will just do it again, right? Okay, so now the question is it possible for us to do like one pass? I doubt it. Actually, I think probably there is a way. Because if you take a look, you do this 2 rounds and then it just takes a lot of... It's slow for one. It's like really slow. It's really slow, 25%. And it uses a lot of memory. So I was trying to think, is it possible to do exactly the same thing, but without running it twice? That's the question. How do you do it without doing it twice? We could do it in place, you know? Yeah, we could do it in place, so we don't. So, okay, so not the best idea, I feel, but it's okay. Yeah, I wonder if it's gonna make it faster. Probably not, but so we try to modify in place. This is still good, that we don't need this. Do we need this? I don't think we need this. So we start from the last one. Okay, this gets out. Times 2. We assign the value and then move on to the next one. Okay, so I think tail, and let's call it tail. Right, C is this, and while node, right? And we'll do exactly this. CV is node val times 2, right? And node.next, node.val shall equal to v, and node equals to node.next, right? I'll try it again. Blah 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 until the last one. The last one, node become none. Right? Node become none. That is not what we want. Okay? That is not what we want. Okay, I don't want this, so I probably need to check node.next. How do we handle it with grace? So node.val. So maybe we can do node equal to val, right? And then node equals to node.next. Maybe I'll check. Well, can just check here, right? Node if not next. If we have the next, we move to the next. If we don't, right? So now when we get out, node is the last one, so we can do this. Node.next, we add one. node equals to node.next, and then we will reverse, because it starts with tail, right? So we start with tail, we reverse it, and node is already pointed to the last one, right? Yeah, node.next, now we go on next, and then we return. Okay, let's try this one. 27. So we do this in place. Does it work? Not really, not 100%. The first one got some issue. A7 is right, and now we become a little bit wrong. That's all right. We're modifying and doing stuff at the same time. So node is the tail, which is fine. Node.next CV is node.val. That's good. And node.val is this value. Carry on, move on. And then if node.next, node equal to node.next. I think the last one was not processed. Maybe I should just do this while true, right? And then here, I should say node.next, right? If node.next, we go this, then node. Yeah, we have to first handle it first. So let's go while true. And then here we say else break. Right, now we get the last one. Okay, this doesn't work. Yeah, I have to do a little condition here. Let's see if this makes it a little bit faster. Significantly faster if we do it in place. Much faster. One pass, no reverse. All right, so it is possible to do one pass without reverse. Damn, how'd you do one pass without reverse? Recursion, right? Okay, recursion I can see. Yeah, I can use recursion. Okay, oh wow, I can use recursion. Oh, it's late. I don't have Ghana to do it again today. Tomorrow. I handle the recursion. And I don't know if this one pass just means recursion. Is it recursion? No, it is. It is one pass. Okay, we have to think about it. Alright, that'll be it for today. Tomorrow I'll think about the one pass. I'll first try to code the recursion one, and then we'll think about the one pass. Alright, I'll see you guys tomorrow. Adios.